The internal angles of an equilateral triangle are all measure how many degrees?
Yeah, I can take that one. So one of the things I always mention when we talk about anything related to geometry is really how important it is to understand what the terminology means and all these like kind of academic vocabulary terms. So what we're looking for is in an equilateral triangle, what is the measure of all of the angles? Is it like the sum or is it each angle? I think it's all each of them, right?
Let me go double check that.
What?
The internal angles
Yeah,
all
they
measure how many
all-
degrees? So each,
All
I guess.
measure, okay. What is the measure of the internal angles? Okay. All right, so again, I think it's really important to know what equilateral means, obviously, or you're not going to be able to draw this, but I think, Becca, sometimes you break down what the word percent means, and I think that's really helpful to understand that if you forget what percent means, it's really a combination of these two words, a compound word. So we have this,
Excuse me.
Equi, and we have the other word lateral. I'm realizing I'm writing really small today for some reason. You know what I think it is? I changed my screen at school, and so now it's kind of messing
You're
up
just
how I write.
used to
Everything's wider now.
in
Anyways,
the habit of it.
so sorry, it's a little bit small today. So what we have here is two words, equi and lateral, and they're just combined. And if you ever forget, I mean, you can really think about what does equi sound like. Well, it sounds like equal. And then if you think about what lateral means, lateral just means to the side. So if Sam and I were playing football and we were on the same yard line, I tossed him the ball, that's called a lateral because it really just means sides. So when we talk about equilateral, what we're really talking about is just equal sides. So I'm going to go ahead and draw that on here if you're not familiar or you don't remember. This means that all of the sides are going to be congruent. So in an equilateral triangle, all the sides are congruent, which means, and I won't get too into this right now, that all the internal angles also have to be congruent. If you kind of think about this, I like to think about it like if two people were standing here and they started walking apart from each other at these angles, eventually they would be a certain distance apart. Well, if two people start over here and kind of walk the same angle, the same distance, like everything is going to be the same. So when we have equilateral, we could just also say that they're going to be equiangular, which means all the same angles. So we should also know that in a triangle, no matter what the triangle looks like, it could be an obtuse triangle, a acute triangle, or equilateral, the angles are always going to add up to 180 degrees. So if you think about this, and I want to know all the angles, so I have x, y, and z, what we're saying is angle x plus angle y plus angle z has to equal 180 degrees. And then if you get stuck with that, you're thinking like, oh, I have too many variables. I've got 3 variables, and I've only got 1 equation. Well, this is where in math, when you're in that situation, sometimes it's not possible to solve. But I guarantee if you're in a geometry class, there is a way to solve it. So when you see those situations, what you should be thinking about is there a way for me to relate kind of all these variables to each other? Like, are they all going to be the same? So what we can do is instead of using 3 variables, even though we have 3 unknowns, we could say that, look, if this is angle x right here, and we know that all these angles are congruent, then we can call this angle x, and we can call, instead of angle z, we can call this angle x too. So then what we have is x plus x equals 180. And then you simplify that and you get 3x equals 180, divide by 3, and you get x equals 60 degrees. So this is the measure of every single angle inside of an equilateral triangle because they're all equal. Another way I like to think about this is, if you ever forget, is that you have 180 degrees to split among your 3 angles. Like Maybe you want to split 180 degrees between your 3 friends or whatever. It's a weird scenario. But how much is each going to get? So if you had $180, you would just divide it by 3 and each person would get 60. And it's the same idea here. We have 3 angles. They all get their same kind of piece of the triangle. So you just divide it by 3. But I think it's more important to understand how to write these algebraically and to relate kind of different angles that have the same measurements.
Yeah. And the reason that he says that also is just because that's also preparing you for future problems that you will be solving with equilateral triangles
Right.
in geometry and things like that.